Hello and welcome to today's video. In today's video, I want to be going over a basic introduction to the idea of a limit. So, sometimes a function will have an x value that is not inside of its domain, but it can be defined around said x value. And in fact, I have a function right here that is completely defined for every value except for x plus 2, or sorry, x minus 2, which is just x is equal to 2. So, this idea of a limit is supposing, what if we get really close to this value of x, but we're not at x, to see what the function is equal to at said value of x. And this idea here is called the limit. And the limit's notation is going to be as follows. The limit as x approaches a, where a is an x value, let's say that in this case a is equal to 2, of f of x is equal to L. So notice that it's not equal to f of a, it is equal to L. And sometimes L will be equal to f of a, but it also might not be. So it is important to have that distinction in mind, that the limit of f of x as it approaches a does not equal f of a always. And this is read out as the limit of f of x as x approaches a is equal to L. So I have some problems here that I'd like to look at. So let's take a look at this first one. So as x approaches a, which in this value I want to find a as x is equal to 2. So let's find the limit as x approaches 2. Well, first we take a look at it from the left, and this value looks to be getting really, really close to 4. Let's say I plug in like 1.9. Well, 1.9 squared is going to be like, I don't know, a number. Give me one moment. At 1.9, x, or f of x, is equal to like 3.61. At 1.99, x is equal to 3.96. At 1.999, again, as x is just getting closer and closer to that value of 2, x approaches 3.996. And what if we add in another, what if we get even closer, 1.9999? Well, it's equal to 3.9996. Apologies. And if we take it even closer with 1.9999, we will get a value of 3.9996. And as we can see, it's going to approach this value of 4 from the left. Now let's take a look at it from the right. So, as we like say 2.1 and square that, well, 2.1 squared is 4.41. That's pretty far away, but what if we get even closer? What if we do 2.01? Well, now that's equal to 4.04. Oh, that's getting really close. What if we add in another 0? Let's say it's 2.001. Well, then that's going to be equal to 4.004. And as we can see from both sides, this limit approaches 4.004. So we can say the limit of f of x as x approaches 2 is equal to 4. Alright, let's take a look at now how this looks whenever we're looking at it numerically. Well, I got a table, and this table is g of x, and we have x. Well, we can see whenever we're like 0.5 away from our point of interest, let's find the limit as x approaches 2. Well, we see that as it gets closer, let's see, 3 at 1.5 it's 3, at 1.9 it's 3.1, at 1.999 it's 3.145, and then at 1.9999 it's 3.1459. Well, that looks like it's approaching pi. And let's look at it from the other direction. Well, at 2.5 it's 3, then 3.1, 3.1459, and then we have 3.1459. This limit, as g of x approaches 2, is equal to pi. Alright. Let's now talk about one-sided limits. So, a one-sided limit is denoted as the limit as x approaches a from the left of f of x is equal to L, or the limit as x approaches a from the right of f of x is equal to L. So this positive, this plus or this negative really does not mean like plus or minus or negative or positive. What it really means is this negative symbol means left. And this positive, this plus sign, means right. And that's really what we're saying. We're saying that we're going to approach the function either going from the left or to the right. Now, it's important to note that a function is only going to, or a limit will only ever exist if the limit as x approaches a will only exist if the limit as x approaches a from the left of f of x is equal to the limit as x approaches a from the right of f of x. And this is this really is the basic idea of a limit. We want to know what happens whenever it's approaching a certain point. Sometimes we may want to know from the left or sometimes from the right, but we want to know what's happening near this point, not at this point. So I have some practice problems for us to work out here. Quite a few of them, actually. So I'm going to change, well, blue actually works. And I've got these graphs here. So on this first graph, g of x, the first question is the limit as x approaches 2 from the left of g of x. Well, we want to take this limit, and as we can see graphically, this is approaching 0. Well, let's see about what happens whenever we're approaching it from the right. Well, it's going to get closer and closer to 0 as well. Well, if this limit, the limit as g of x approaches 2 from the left, and the limit of g of x approaches 2 from the right are equal, then the limit as g of x approaches 2 is equal to 0. I'll give you a moment. You can probably work through the rest of these by yourself. Alright, let's work everything together. So, this next problem, we're approaching f of x from the left. So we're looking at this, and we know that this is we want to know what happens at 0, so we're approaching 0. Oh, it's equal to -1. Well, if we approach 0 from the right, it's equal to +1. Well, that's an issue, isn't it? They don't equal, so the limit does not exist. DNE is the abbreviation for does not exist, and it's commonly used math notation. I am going to real quickly move that to the top. Alright, let's work on this next one. So this one has a lot more areas where things can go wrong, but this is just a lot more learning opportunities. So I'll give you a moment, work through it. Alright, let's work through it together. So the limit as x approaches 0 from the left, so we're really looking at over here. Well, that looks to be approaching 2, so we're going to write it down is equal to 2. The limit as x approaches 0 from the right, on the other hand, that's equal to -2. So what this tells us is this limit does not exist. However, now let's look at this next limit, the limit as x approaches 4 from the left. Well, it looks to be approaching this value of 3-ish. So we're going to say it's equal to 3. Let's see, from the right, it's also equal to 3. So then the limit as x approaches 4, since the limit from the left and from the right are the same, is equal to 3. Alright, let's look at limits at infinity and vertical asymptotes. So, these limits are surprisingly enough able to tell us a lot. So, an infinite limit is going to be what happens at a. So we're going to be looking still at a limit as x approaches a. But what happens if a gets really big or really small at this value of x? Let's say there's an asymptote. Well, the value of f of x is going to approach infinity or -infinity whenever it's approaching a. And that's the idea of an infinite limit. Well, what do these infinite limits really tell us about the graph of f of x? Well, if the limit, and I'm going to give you several cases here, give me one moment. What you'll see is if any of the following of these are true, then there's going to be a vertical asymptote at f of x at said point. So if I said the limit as x approaches, or I'll just use actual limit notation, as x approaches a of f of x is equal to -infinity, and let's call this a value 2, and sketch a graph of f of x, this will tell you where to place a vertical asymptote. So let's do that together. Well, we are going to want to go 2 over, and we also need to define an area around it, so let's just do 3 over. We are going to sketch in our vertical asymptote. And notice that this isn't a one-sided limit, so we know that x must be approaching -infinity from both sides. So we are going to perhaps get a graph that resembles something on the lines of a natural log of the absolute value of x minus 2. And of course, this is a very vague statement. You can make this graph be anything you want it to be. All that we know is the value of the limit, but that's what the limit tells us. I have one last problem for us to work out, and by that I mean like, not like 9 problems, but I'll give you a moment if you want to work these yourself. Alrighty, let's work them together. Well, the limit as x approaches -4 from the left, well, that approaches to be about -3. And as it approaches -4 from the right, that once again approaches about 1. So the limit as x approaches -4 does not exist. Well, once again, as the limit as x or f of x approaches 1 from the left, well, that looks to be about 5. As it's approaching from the left 5. Well, what happens whenever we approach it from the right? Well, that's also 5. Well, that means that the limit is 5. Well, now let's look down here at x is equal to x is equal to 4. Well, it looks like these approach -infinity, so -infinity from the left. As we get really, really close to 4, it approaches -infinity. And as we get really close to 4 from the right, it also approaches -infinity. So the limit is also -infinity. I would like to note the following, that even though the textbook I am using will denote s or limits as approaching infinity as infinity, sometimes approaches a of f of x is equal to infinity. Sometimes other textbooks or other teachers may say the limit as x approaches a of f of x does not exist. And this is actually equally true, because f of x is not really approaching an actual value or a real number. Infinity is not a real number. And that is something you have to understand for limits. But that's all I have for you today. I hope you all have a wonderful rest of your day and found this video informative. Have a great rest of your day. Bye-bye.